All right, side-by-side comparison of two mean t-test versus matched pairs. So these are two separate problems because it takes two different types of context to be the two different kinds of things. So first, the two mean t-test we're going to look at, the example, is a random sample of 13 men and 19 women in a college class and their reported GPA. And they had given us histograms of the data in the original prompt. That was a histogram for the men data and a histogram for the women data. And both of those histograms, by the way, were somewhat symmetric, unimodal, and had no outliers. Okay. Then, so the data we were provided was the summary statistics. So we were given the average for the means GPA and the standard deviation for the means for the men's GPA and the women's average GPA and their standard deviation. So a woman in the class says that she believes the college women tend to have higher GPAs than the college men. Does this sample support her claim? Okay. So let's kind of just study these first two boxes here, the problem and the parameter. So look at the parameter. We have two independent situations. We have two independent samples, two means. The mu of the M is the average GPA of all such college men, and the mu of W is the average GPA of all such college women. Okay, let's take a look at this matched pairs situation. So this is an example about whether taking AP statistics decreases students' anxiety about statistics. And so the AP instructor gave a test to rate student anxiety before the course and after the course. And here is the data for 16 randomly chosen students from her 180 students. So we had the pre-anxiety score and the post-anxiety score. And so you can see that, say, this is subject number 1. So that is one student. And this was the fifth student, okay? So we determined that you can see subject 1, student 1's anxiety went down 3 points, and student 2's anxiety went down 3 points, and so on. Over here, we had some students whose anxiety stayed the same, and then, unfortunately, we have this last student over here whose anxiety increased. Okay. So the question was, do the data indicate that the average anxiety level amongst this professor's students decreases after the students take the AP statistics course? So here we go. Let's look at what the parameter looks like. So notice we are just interested in one average of those differences. And so mu of A minus B. So you could have done post minus pre or whatever. So look, here was two independent means, but here's one. So all I'm going to be doing is get an average of that one highlighted row. So the average change in anxiety level after the students take AP course, and I defined the way I subtracted. Okay? You want to make sure this has not only the word average, but average change or average difference. Okay? So that's important. Average change or average difference. Okay. So let's now look at how do the hypothesis statements look different. So here we go. Okay, so when we had two independent means, the null hypothesis set those two separate means equal to each other. And then the question was, do the women have higher than the men? So mu of M is less than mu of W. Look at this over here, though. Our hypothesis statements is about one mean. And is the average of those change in scores 0? Or has the average of those change in scores, has the anxiety level decreased? So that's less than 0. That would mean after is less than before, so that's less than 0. Okay. So let's look at how we do the assumptions. So here it was stated that we had 13 men and 19 women were randomly selected. So that's it defined two different sets of subjects, but here we are just defining when randomly selected one set of 16 subjects. Okay? Look at how this independent is handled. We said that 13 was less than 10% of all such college men, and 19 is less than 10% of all such college women. And those men and women, GPAs are also independent of each other. We didn't count any of those in both groups. But over here, one set, 16 students, is less than 10% of all this professor's students, because we were told she had 180 students. And here is how we do that little extra thing. Each student's anxiety levels are independent of the other students. So each pair is independent of the other pairs. Okay? Now, these samples on this men and women example, they were not large enough. They were 13 and 19 are not greater than or equal to 30, but they did the provided histograms that I didn't put here were showing that both sets of data are somewhat symmetric, unimodal, and had no outliers. So the approximately normal model applies. But a dot plot or a histogram was not provided for this second problem here. So there's not large enough. 16 is not greater than or equal to 30. So I had to make myself a little picture. Let's kind of look at this real quick. So your frequency, of course, is on that y-axis, the number of students, the frequency. Look at my label on this x-axis. It's the difference in anxiety level, the post minus pre. I did the post or I could say after minus before. Okay, either one. Okay. Something that is also interesting is, remember that these numbers up here were -3s, -2s, -1s, and 0s, and so on. So that was interesting, because the thing that is interesting about this is that, like, this line right here is 0, a difference of 0. So it's kind of weird. So see, look, I went ahead and I had put my little railroad tracks in right here, because the y-axis did not represent 0. It was at -3, -2, -1, 0, 1, and 2. So that was interesting. Okay. But it was very nicely symmetric, somewhat symmetric, unimodal, and no outliers, so the approximately normal model applied. Okay, so there's comparison so far of the parameters, how they looked different, hypothesis statements, how those look different, and then how we did the two different sets of assumptions for those two. All right, so let's move on. The name, to sample t-test for means. And then this year I'm calling it a little different, because I noticed in AP criteria, they called it something a little different. So let me write that down here. So they call it to sample t-test for means. Okay. And our calculator does also. To sample t-test. Okay. And then over here, I taught you to call it matched paired t-test for means. Okay. All right. Or you could call it one sample, one pair. Anyway, paired has to be in there in that description. Okay. So let's look calculator-wise how this was different. So for this problem, if you remember, we were given the summary statistics. So for the men and women problem, we were given the summary statistics of their mean and their standard deviations. So when I did it with my calculator, I used the summary statistics tab, and I put in the men data first and the women's data second. And make sure you pay attention to the way you're doing your symbol, that we wondered if men was less than the women. Okay. And contrast that with our matched pair, where we are only interested in this one list of differences. So that means I did not do a 2-sample t-test in the calculator. I did a t-test, 1 sample. Now, I've told you to do those by hand, and you could go do that and everything. But since we're putting this data in, let's go ahead and do it in calculator also. But so we had the raw data. So we had that input of the data. The null hypothesis is an average difference of 0. See here on this page right here? That was the null hypothesis, was an average difference of 0. So in my calculator, that's what this is saying, an average difference of 0. My data is located in list 3. And I was wondering if that average anxiety had gotten less. Okay, so these are the results that plopped out from the calculator. And so I just wrote those straight down from the results of the calculating. Notice, FYI, there was no pooling there. I noticed that. Okay, so obtain your p-value and compare to alpha. In both cases, we rejected. So let's look at the conclusion and careful wording. So here we go. So let's see. Since the p-value is less than alpha, I reject HO. So there is evidence that, watch this, the average GPA of such college men is less than the average GPA of all such college women. My language used the 2 different averages. Average of this is less than the average of that. It's not the same for this other conclusion, so let's look at it. There is evidence to suggest that let me scoot this up here, that the average change in anxiety level after they take the AP course decreases. I only stated the word average once, and it was about the average change or the average difference. Okay, very important distinction. Average, 2 separate averages, not 2 separate averages here. Average change. Okay. But how would this look if we had done an interval? So let's kind of we know that our parameter and assumptions would have been the same. We would have called this, let's talk about what we would have called it, a 2-sample T interval for means. Okay. And then over here, it would have been the matched pairs T interval for means. Okay, so there's kind of what I called it this year. So when I went to my calculator, I guess I didn't show the calculator printout or how I put it in my calculator. Okay. But same idea. You're going to just go to the 2 sample t interval and compute this. So look here. Very important. Define 2 separate means. The mean of the men minus the mean of the women. And we'll talk about what that interprets to in a second. Degrees of freedom were 19.44. Over here, look, one mean of the average after minus before. And here's these numbers, also negative. Degrees of freedom, 15. Okay, so let's talk about how you conclude these and how do those conclusions compare to each other. So here we go. So again, we've got this situation where on the left, I am 90% confident that the average GPA of all such college men is between 0.82 and interesting, because these were negative, that's kind of weird to say negative GPA and stuff. So we're not going to do that because in layman's terms, that doesn't make sense. So I stated them from least to greatest. So the average for the GPA for the men was between 0.045 and 0.82 points lower. So this is really important. Do this. We didn't use negatives, and we did it from least to greatest. And we said the GPA for the men was lower than the average GPA for all such college women. Okay, so look at that. 2 separate averages stated and the difference between those two. And since 0 is not in the interval, this further suggests that there really is a difference between the average GPAs of college men and women. So see, my language is really distinguishing that I have 2 means right here in that problem. Let's contrast that with our conclusion for our paired data, our 1 mean. I am 95% confident that the average anxiety level after students take the course, 1 average level. The average, it would have been better even if I had said the average change, but by using the words the average after they take the class is indicating that change decreases between 0.62 and 1.63 points. See, and it's entirely below 0. So since 0 is not in the interval, this further suggests that average anxiety level after the students take the course decreases. All right. So big deal. I mean, I think, man, this is the first year I really put the time into showing that details of of those 2 different tests side by side. And I think it just really solidifies the difference in those 2 different types of situations. So what we then have next is an example that you could practice. So maybe you could go through and try to do this. I'm going to do this example in a 3rd video. And so you could try this on your own, see how you do, and then come and check that when you're done with that. All right. So good luck to you.